Welcome all the students in our YouTube channel Physics by TC Chauhan sir. Today we are going to discuss another application of Gauss theorem, in which we are going to find electric field intensity due to line charge. Whenever you have to find electric field intensity due to line charge, you have to draw a Gaussian surface for line charge, and that Gaussian surface should be cylindrical. On that cylindrical surface you have to take electric field vector, area vector and their direction. So in cylindrical Gaussian surface there are basically three surfaces. One is curved surface and two are spherical surface. On that basis you have to find electric field intensity taking angle between electric field vector and area vector. By using that you can take Gauss theorem, that is integration E dot dA is equal to sigma q upon epsilon, and in which whenever there is a line charge, then there will be line charge density lambda is equal to q upon L. We shall use about that. Let us discuss about that. So to find electric field intensity due to infinite line charge, first of all we have to find the direction. Let this is a line charge. Infinite means dotted sign are taken at the ends. We have to find electric field intensity at this point P. For this purpose, here we take an elementary charge dq, here also we take elementary charge dq. Due to this elementary charge dq, the electric field will be dE, and due to this it will be dE directed as shown in figure, and then we have to take its component. Component of this dE will be at angle theta. It will be taken dE cos theta. It will be taken dE sin theta. Here the angle is same, so it will be dE cos theta again, and it will be dE sin theta. So vertical component will get cancelled and resultant will be due to horizontal components. So we can say that electric field intensity will be perpendicular to the line charge as shown like this, perpendicular to line charge. Then what about the charge density, linear charge density? If charge is q and length is L, then line charge density lambda is equal to q upon L, then q is equal to lambda into L. This is very important, it can be used. Now what about determination? So for this purpose we have to take a certain length L and we have to find at a certain distance R. For this purpose, determination of electric field intensity, we consider a cylindrical Gaussian surface like that. It is cylindrical Gaussian surface like that. On this surface we have three surfaces. S1 it is curved surface, S2 it is spherical, and S3 it is also spherical. So on curved surface, E vector and dA vector, electric field vector and area vector are in same direction, so theta will be 0. Here E vector and dA vector are mutually perpendicular, so theta will be 90. Here E vector and dA vector are mutually perpendicular, so theta will be 90 here again. So this is about the angular formation EDA, EDA and EDA. Now how to find? It's very simple. Integration of E vector dot dA vector is equal to sigma q upon epsilon naught. It is having three faces, so we have to take like that. Integration S1 E dA cos angle, here for S1 is theta is equal to 0, plus integration S2 E dA cos 90. For surface S2, E vector and dA vector are mutually perpendicular, so angle between them will be 90. And for S3, E dA cos 90 is equal to sigma q upon epsilon naught. This is for S3 surface. Now what about that? Integration E dA cos 0 is 1 plus 0 plus 0 is equal to sigma q. Sigma q is q upon epsilon naught. E is taken outside. E is taken outside, and integration of dA is equal to q upon epsilon naught. What about integration of dA? Integration of dA means surface area of curved surface. Length is L and radius is R, then its surface area will be 2 pi r L. And what about q? That you know, q is equal to lambda into L. This is given. So here we have to write lambda into L upon epsilon, L will get cancelled, E will be lambda upon 2 pi epsilon naught R. Whenever we are going to multiply 2 and divide by 2, you will have E is equal to 2k lambda upon R, where k is 1 upon 4 pi epsilon naught. In vector form you can write E vector is equal to 2k lambda upon R cap, or you can write E vector is equal to 2k lambda upon R square R vector. This is about electric field intensity due to line charge. This is the formula finally obtained. And what about the graphical representation? If you are going to draw a graph between electric field and lambda, it will be a straight line. If you are going to draw a graph between E and R, then it will be inversely proportional like that. So this is about the graphical representation. Here it represents that E proportional lambda. Here it represents that E proportional 1 upon R. It is very much shown in the formula E is equal to 2k lambda upon R. It is very much shown in that, and that is in front of the electric field intensity due to a infinite line charge. This was all about electric field intensity due to line charge. It is very helpful whenever numerical question which are dependent upon the electric field intensity due to line charge, as well as its derivation is helpful in board classes. For 12th board class, it is very helpful. It is very important as well. So I think this video become useful for you. Please do subscribe, share and like our YouTube channel. Thank you very much.